Okay. Okay. So the professor commented on our group meeting last time and said that it was short and asked if we recorded it all, and I'm like, well, there's nowhere to respond to it.
Yeah, I read that too. I was like,
Yeah.
Like, I guess they're efficient. So.
I think we're supposed to be doing the part 2 together, and I think we're all doing it on our own.
Okay. Because this is the only time
yeah.
I've seen it say to do it during the group meeting. I'd never read that before.
Yeah, starting on like 5, it said you will fill out this with your group, but I've always done it ahead of time because I have to watch the video some of the time.
Yeah.
Go back and go, wait, I don't understand this. I have to figure out what are they talking about. So.
Yeah. Okay. Well, should we just like, I don't know. They already give us the answers. I didn't have too much problems with any of them.
No,
I
thought
this
one was.
Let's see.
I thought they were.
That wasn't too bad actually.
Yeah.
Yeah.
Okay, should we just start the quiz then?
Sure.
Do you guys have any other questions?
Yeah. Be good.
Okay. Okay, let's see. There's the applet to find the combined area. Is right. Right.
1, 2, 5, 8.
Okay, I got 0.175.
That's what I got. Okay.
Okay.
0.175, yeah.
Mm-hmm.
Okay. Let me see.
Okay, so I'm kind of confused by the wording, what we're supposed to mark for the
Yeah.
I got a
output.
weird number. I have no idea what is going on.
As extreme or more extreme. We're not only interested in the values of the because they're saying, it makes it sound like they want everything. Or maybe like between the mean and the observed mean, and then
Right.
above. But that would still be like half, wouldn't it?
Probably.
As a stream or more extreme. Not as extreme as a lower. Is as extreme or so I think there ends. That's my guess.
So are they asking for the 185 minus the 177.6?
Yeah. Or the other way around, but yeah. 177.6 minus 185. And when they say as extreme, I think they mean as far away from the mean. And then anything more than that. So I think it's the two ends. Let me know when you guys get an answer.
So -2. Okay. Negative 0.277.
Whoa, I did not get that.
Okay, so
Let me try it again. So I used 177.6 minus 185
okay.
over 175 radical 48.
Yeah, I got that in the beginning. I got like negative the 0.04 or something like that.
Okay,
I
I
think I
should
got that.
try it again because I got negative 1.92.
Or maybe I did it wrong. Because, let me see.
Let me check mine.
I thought I was doing it wrong because the number came out ugly. I was like, let me just keep trying.
Well, I think it's because we have that radical 48 that makes it ugly.
Oh, yeah.
Let's see.
Yeah, for some reason I keep getting negative 0.04. I don't know why.
Or let me.
What are you using as your formula? Well, what are your numbers that you're plugging in?
Yeah, I'm doing the 177.6 minus 185 divided by the, I think I wrote down 26.7 divided by square root of 48.
Yeah, that should be right.
Unless if it's just not reading, or like I don't even know. Sometimes like I use this online thing and maybe it's not like reading it right. Maybe it's dividing the 26.7 with the other numbers.
Yeah, I would say, because I keep getting the same answer that I had.
Okay.
Maybe try bringing that radical 48 to the numerator instead
Oh
of
yeah.
dividing it and dividing it again.
That's true actually.
Yeah, I still keep getting negative 1.92. What's the z-score? Carly, what was your number that you got?
Negative 0.277.
For the z-score?
Mm-hmm.
Give us your
Okay, yeah.
numbers.
I think I might have got. Well, now I got negative 1.92. Is that what you guys got?
That's what I got.
Okay, yeah, that's what I just got.
So, Carlene, read off your formula.
Well, that's what I'm trying to. So, okay, why are we doing it? Why are you taking the square root of n? That's what I'm trying to figure out.
This is the problem.
Because in the homework, that's where I was getting confused.
I think it's when you have more than one experiment.
Okay.
So you have a few different means. So for this one, we had 48 different passenger.
Because that's what I was debating, whether or not you would take the
Radical
that's weird.
48.
square root of 48 or not.
Yeah. Well, let me look over my notes really quick. I just assumed because that was what the section was focusing on, but
I think you're right. I think you do. Okay, let
Yeah,
me
that's
redo
kind of
it.
why I did it too. Yeah, because that was kind of what the whole thing was on.
yeah.
Okay, let me
And I think also they'd already taken the mean weight of the passengers on the boat to get 185, and then like another experiment they took the 48 passengers. So I think that's why it counts as like a distribution of the means problem. I think maybe.
Okay,
I mean anything.
because I just got a negative 0.04, which makes no sense. Okay, let me try this again.
Okay.
Yeah, that's what I got in the beginning too.
Yeah, let me do it in steps instead.
Yeah.
Yeah, that's what I did. I kind of did the bottom part first, and then the
Yeah.
top part, and just did it together.
Okay. So I think when they say sample mean is what we're using as our like x bar, then we do the over radical n. Because I think for the old problems we would it was a sample. It wasn't a sample mean,
Yeah.
I think, is why.
Okay, I got negative 1.920.
Yeah.
Okay.
Yeah.
And then you have to plug that into the probability applet.
Now, what area are we shading? I guess it's my only other.
I think it's the two extremes because they talk about as extreme means as far away from the mean as the number. So I think
Okay.
they're saying either side of the mean, which ones are as far or farther.
Yeah, that's what I was thinking as well.
Above
And
or
I
below the
got
mean?
0.0549.
Yeah.
Yes. Okay, that's what I got.
Okay, cool. Okay. Which of the following will have a smaller standard deviation if 9 observations are needed, John?
Smaller standard deviation.
So which will be spread? Okay.
I think it would be the sample means.
How come you say sample means?
I would only think that just because with the sample means you would have to um well with the distribution of sample means you would have to get the standard deviation and then divide it by the by the square root of the sample size.
Okay.
And well that's the only reason why I think and then the number would be a lot smaller than with the 9 observations. Well, that's what I would think, but I'm not really too sure.
Okay. I could see that. Yeah, I think my initial guess would be the sample means as well.
I think yeah. I mean, that makes the most sense.
Yeah, I'm just trying to figure out if it would actually do that, you know? Like
Yeah.
between the two, I'd say the sample means, but I don't know if it actually would. Well, I'm gonna pull up that thing we had yesterday. The well, okay. I'm just gonna go with sample means.
Yeah.
Let's see, which of the following results implies that the spread decreases as the sample size increases?
X decreases.
I think it's central limit theorem.
Yeah.
Because that one talks more about the distribution and the spread, and the law of large numbers is about the mean.
Is that the X is the mean, right? The spread in the mean
Yeah,
decreases.
yeah. X is the sample means.
Yeah, I think it might be central limit theorem, but yeah, I think it is that.
Okay.
Yeah.
Okay, quick question about that one before. Is it, we know because we don't know if it's a normally distributed one? We don't know. There aren't that many ends.
For number 5, or
Is it,
Again,
what?
like you cut out on my end, so
Oh, okay. So for number
yeah,
5,
sorry,
just
yeah, I
looking
cut
over
off on
the
mine as well.
theorems. Okay. Let's see if it worked. Um, when we're looking over the theorems, it makes it sound as if you have to be able to know if it's either a big sample size or we have to know that it's normal to determine the distribution of the sample means.
right.
So I feel like since we don't know if for number 5, we don't know if it's normally distributed of that many observations. I feel like it would be cannot be determined.
Oh, I know what you mean. Yeah.
Yeah.
Well, no, well,
Because at the same time, it's weird because say even if it was a large number or a small number,
Mhm.
I think like since it's asking like just a smaller standard deviation, I think just compared to the individual observation, I think the sample means would always just come out to be a little smaller somehow. Well, I guess the number would
Okay.
have to be really large, like super large, for it to be maybe larger than the individual observation, maybe.
Uh-huh. Okay.
Unless the population was small as well. I don't
Yeah.
know. Yeah, that's a good question. Yeah, that's a good observation. I don't know.
Uh,
Maybe there isn't enough information because if one has to kind of guess, then maybe there's not really enough.
yeah. Because they'll want
That's a tricky one.
to say like the equation with the over radical n makes it sound like okay, it's always going to be smaller. But then we can only use that equation when it's normally distributed. And it doesn't tell us if it is or not.
That's true.
Oy.
Yeah, that is true also. Yeah, yeah, I think there's not enough information given.
Okay.
Yeah.
I'm going to put it for now, and then we can come back to it later.
Yeah.
Okay. Let's see. So like, for number 7, I think the z-score does not have that radical n because it's only one sample for one observation. What do you guys
Oh.
think?
right.
Mhm.
Okay. I got 1.045.
Okay, real quick. $1.045.
Yeah.
Yeah. 1.045.
Oops.
And then the next one, I think we can just plug that into the z-score on the applet, right?
Right.
Okay, so I get 0.148.
That's what I got.
Okay.
Yeah.
I get 2.338 for the next one.
Is that one solved like the last one, where it's divided by the standard deviation divided by the square root of?
Yeah. Of the samples. Yeah.
Yeah.
That's what I got. And I got as the mean, just for the 5 people, as 160. So I just kept the last answer and then multiply it by a radical 5.
Oh, okay. Let's see. Let's see.
Okay, I got 0.066. Let me redo this.
Did you get that for number 9?
Yeah.
Okay. Yeah, I got 2.338.
Let me try it again.
Okay, and I'll try it again too.
Yeah.
I still got the same answer.
Yeah, I'm going to get a different answer this time. Putting it in differently. I got 2.338. What did you get?
That's what I got.
Okay.
Yeah. Yeah, just got the same thing.
Sweet.
I'm gonna have to do this step by step every time I do one of these. Not take any shortcuts on this calculator. It does not like shortcuts.
I just use a lot of parentheses when I do.
I try to use parentheses and somehow I miss a parentheses or something because every time I try to do one, it just doesn't like it.
Oh my gosh.
Yeah, that happens to me too.
I'll just keep doing it out by hand. It works better for me.
Okay. So for the next one, I just plugged that in and took the bigger and the most right end.
Oh, so it says to round it to 4 decimal places. That makes more sense. 0.0097.
Yeah. So I
Okay.
got.
I'm sorry, but how'd you guys solve this one? I'm a little confused.
Did you get up to? Did you get number 9 right?
Yeah.
Or yeah.
Yes.
So you're trying to figure out number 10.
Yeah.
Okay. So they're asking for the probability that students will have a mean score greater than the mean achieved. So what I did was I took the z-score we already had and plugged that into the little applet, and then I only marked the very top little section because they are only asking for kids that will have a mean score greater than the one we got.
Oh, yeah.
Does that make sense? And then it just gave
Yeah.
me the number for the area.
Oh, okay. Yeah, like, I don't know why. I never really understand this app, but sometimes I get confused. I might overthink this thing. I don't know what it is.
Yeah, I mean, it's literally just like that in. If they give you a probability, you plug that in what section you need.
Okay, cool.
Okay, the next one, I'd say it's approximately normal.
Yeah, because it's enough that it should be
Yeah.
the law of large numbers.
Yeah. But the next one is kind of tripping me up.
What does it mean as a district?
feel like the mean would just be 3.5. Maybe I'm way wrong, but that's my.
Yeah, I think it would have
isn't
to
that what's
be.
from the last? Because isn't that from the last time? Isn't the distribution of the sample means? I mean, isn't that from the homework from the last lesson?
Yeah. Yeah, that's what I
Yeah.
was thinking too. I was just like going back
I
to
was
the
like, are they
lesson
made?
to make
Because that
sure.
was really confusing to me. Because the distribution of sample means is
Yeah.
the mean.
It's just the mean, yeah.
Yeah, unless it's a smaller amount, like how the whatever that last one was with the 160 being the mean.
Right.
But with 81, I think is just the same.
Yeah, it should be because just because this lesson kind of goes off of the last one. It's like both together.
Yeah, yeah. It's building on itself.
And that's what statistics does for sure.
Hey.
Yeah, don't get lost. You'll be in trouble.
Yeah, seriously. So, okay. What is the standard deviation of the sampling distribution?
That would be the point.
That'd be over radical n, right? Would it be? Boy. Shoot.
I thought it would just be the 0.7. What is the standard deviation of the sampling distribution of the random variable x, the mean of the 81 students? So is it the 0.7 divided by the 81?
That's what I'm trying to figure out.
Yeah, I thought it was just 0.7. Maybe I was wrong. Let's see.
The only reason I want to say it's with the radical n is because somewhere it was saying it wrote out what the z-score was for the distribution of means, and it was saying that's equal to the value minus the mean over the standard deviation. And then when they plugged in standard deviation, it was the little circle guy over radical n. So it was saying
Right.
that was the standard deviation, like that whole thing.
Oh,
Yeah, if you look at it back, it's
It says of a random variable x bar is mu, and the standard deviation of x bar is the standard deviation sign over radical n. I should find that in the textbook. So I found that it's in that very first section, like the fourth bullet point down
right.
for the
Yeah, because
textbook.
it's
I think it would still be 0.07 or turn into 0.078 or something. Let's see.
Wait, what? Explain.
No, I think I was just doing some like weird calculation, and I think it sort of just came out to the same number.
Oh, really?
yeah, it does. It comes out to point. Even when you do it, it comes out to 0.07. To three decimal points, it comes to 0.078.
Yeah.
Yeah. I mean, it moved it over, though, one decimal.
Oh, yeah, that's true. Yeah, because there's a 0 in
So
front.
it'll make a difference which one we pick.
Yeah.
I think I'm going to go with the 0.078.
I think that's what it is.
Okay. And what is the probability of the mean? Less than 3.3. Okay, for the z-score, did you guys get negative 2.57? Or let me know when you get it.
Not yet.
Negative. No. Let me redo mine. I got negative 2.56, but I was using that number 13 as my standard deviation.
Oh, okay. I just plugged it all in again, but it probably gets the same probability, though.
Oh yeah.
Let's see what that makes it.
That gets like 0.001 off, but I don't know what she wants us to use.
Is it just shading the left part only?
Yeah.
Says it 0.0051.
That's what I got, yeah.
Yeah, because even
Did you say something, Carlene? And
nope,
then
that's
get
what I
cut
got
off.
even when I changed it. So
Okay. Probability will be greater than 3. You guys get 0.9949 for that next one. Okay. I just rounded that to 0.995.
Point 160, I guess.
Wait, what? 0.160?
For the area of the z-score.
Okay.
Or
For number 15?
yeah.
Are you working on 15? Okay.
Would it? Because yeah, 15. Sorry. Would could we would shade the right part, right? Only now.
I think you shade the right part and the middle part because you're going from greater than 3.3, and 3.3 is that left line. So I think it wants everything to the right of the left line.
Oh. Okay.
Yeah?
That makes sense. Oh, so it'd be
Okay.
point
But
eight
you didn't
four
say-
zero.
yeah, that's what I mean.
Wait, 0.840. I still got like a 0.995.
Yeah,
Is that what you got, Carlene?
that's what I got.
Okay. Hey, what'd you put as your z-score?
Let me see what I'm doing. I got 0.995.
There we go.
Okay.
Oh yeah.
Okay, that's right. Okay, you guys ready to submit?
Yeah.
Yeah.
Just before we submit, sorry. Did on number 13, I think it was that I was. Did you guys get 0.078?
Yeah.
Yes.
Okay. Yep. Let's do this.
Okay. I really hope that one is right. Oi! You! Is there?
Oh yeah, they do that. Yeah, I think just in case someone else still has to take it.
Okay,
Does
wait.
it tell you what we got wrong?
Yeah, we got wrong the two that were multiple choice, like this cannot be determined. So it's got to be the sample means. And then the central limit theorem one we got wrong. Spread decreases as the sample size increases.
And it doesn't.
And it doesn't say what the right answer is.
Yeah, what would that one be? Because I don't think it's the law of large numbers then.
That's what you think?
Well, no. Well, those two are a little confusing, but I don't think it's that one either. Unless if it's
Yeah.
normal distribution, because I don't think it's the rule.
Which of the following results implies that the spread decreases? I guess it could be that, but I thought normal distribution is just like if you have normal distribution, it's automatically normal.
Oh, well, yeah, that's true.
But it's definitely not that 68, 95, 99, 71.
Yeah, it's definitely not that one.
I totally thought it was the central limit theorem.
I bet it's the law of large numbers. Because it's the
Yeah.
sample size increases.
Yeah.
So if your sample size increases, which means you're going to have a larger sample size. Yeah, I bet it's that. I mean, that makes the most sense. I bet it's the sample size increases.
Oh, you know what? Yeah.
Because as soon as your sample size increases, then you're going to have more of a chance of it getting closer to the mean or the.
Yeah. Yeah. And I have it, but the standard deviation is going to get smaller. So the spread will get smaller as it sample size increases. Oy. Okay, and what about number 14? Like, mine says that the area of the left tail is 6.4, but he wanted us down to decimal places.
Yeah, I was looking at the same thing. I was like, isn't that it?
Yeah.
I got 14 right, 0.005.
I had it the 1.
I have an extra decimal
Oh,
place.
Because it
crud.
says to 3 decimal
Dang
places.
it.
Yeah.
Yeah.
Oh,
See, I don't
man.
know why I had 4. Oi.
You have to read it because that's what I was doing. Like I always double check all of those because I always mess
Yeah.
up on those,
Oh, man.
Oi. Okay.
especially on exams because that will kill you.
Oh my
Oh,
gosh.
now I'm actually kind of nervous because the exam is like the next lesson, right? Or something like that?
It's pretty soon, yeah.
I think it's next week, yeah.
Yeah, like the exam review is
it?
pretty soon.
Yeah, the exam review is the
Yeah. It's
next
an online
lesson.
exam, right?
Yes, we don't have to have a proctor,
Okay.
so. But
Okay.
I've messed up on so many exams because I did not get the right number of decimal points.
Oh, man.
Oh my gosh. I thought we had this one too. Dang it. Oi.
Sometimes he reviews it, so like sometimes like he might like go through it and say, "Yeah, I'll give him a break," because that's what happened to one of my classes as well.
Okay.
But
Hopefully. Hopefully.
yeah, sometimes we're not that lucky.
Yeah.
I am curious about that one, if it is the law of large numbers, because that's been very confusing. Trying to understand the difference between the two. I've been watching videos on it and everything, and I still don't totally understand the difference between them. like well enough to explain it to somebody else. I'm like, oh, get that.
Yeah, I wouldn't
Yeah.
doubt that it is though, just because they're so similar. So if it's not one, it has to be the other.
Yeah.
Yeah.
Because I
Oh,
went over my notes
no.
and I was like, I still don't. The parent population is normally distributed and the sample size is large. I'm like, that doesn't still make any sense to me. I'm like, okay. That question still, I couldn't tell you
Yeah.
really what the answer is.
Yeah, I think the central limit one is the one that has to do with, like, helps you figure out if it's normal.
Yeah.
And I guess the law of large numbers helps you with the standard deviation, but oh my gosh. Yeah, well,
Yeah, that was tough.
I bet
Was a
this video
good
is long enough.
good meeting. Yeah.
Yeah,
Long meeting. Hopefully he'll be happy.
yeah. Oh my gosh. Okay, well, do you guys want to do 5 again?
Sure.
Yeah.
It might be
Sure.
a little tough just because because I'm 3 hours ahead, so then it'll be 8,
Oh,
and sometimes we go depending from 8 to 9 that we start family home evening, so it might be a little tough for me on Mondays.
okay.
Okay.
Should we just do Tuesday then? Tuesday and Wednesday instead?
Yeah, if you guys don't mind, I hope I don't like kind of cramp your schedule, but
No, that's
Oh,
that'd be
no,
fine.
it's
great.
okay. Yeah. Because Mondays I wouldn't be able to stay later than 6:30 here anyway.
Yeah.
So I couldn't do it
Oh,
much
okay.
later.
Yeah. And I travel a
But
lot on Monday, so that's fine
okay.
by me.
Sounds good.
Oh,
So
perfect. Yeah, so
Tuesday,
Tuesday and
Okay.
Wednesdays, awesome.
All right.
should we say 5? Let's say 5. I think my group meeting should end by 4:45 on Tuesday.
Okay.
Let's try for 5.
Okay.
Perfect.
I'll
Sounds
email you
great.
guys if it goes over.
All right.
Cool. Sounds good. See you guys.
Okay.
All right. Thanks. All right.
Bye bye.
Bye.
Bye.